Hi friend, again here before continuing algebra of complex numbers, I will continue again here geometrical interpretation of number. And knowing that now, if we can take any complex number, that is equal to x plus iy, and y these are the real numbers, and I is equal to this is our complex. How we are denoting this complex number in graphical way? This is our axis, this is our imaginary axis. For our convenience, I will take this point x and y, and I will try. Here, what I will do for this complex number, I will take another number, third one, and I will denote this number as x minus I1, and I am denoting this number as x minus I1. Here is x, and here is because x. For this complex number z1, we will get coordinate as x minus 1. Therefore, how we will denote this complex? X is same, but instead of y, we have to write. I will write sub. Let this coordinate get here. X. This is my complex. That 1 is x minus. That means this is a, if this complex first quadrant, this quadrant, first quadrant, then we'll get position third one, which is only just I'm changing by sign of imaginary part. Then this is in our fourth. In our fourth. Or I will take here another example. If my complex number I will that one is equal to minus x plus iy and z2 equal to minus x minus I. What I am doing here, I am changing sign, imaginary part. Plus in sign, I have changed the sign as minus in sign. Only I am changing imaginary part. And we'll get here minus 5. Here is 1. This is for third and this is for third. Here, in this example, another. Here I will say this is Z2 and I'll try to plot graph of and Z3 in between that plane minus x somewhere I write and y is and we are getting this coordinate at minus x Z2. I will plot Z3. I will plot Z3. Z3. Whose first coordinate is minus x. Second coordinate is minus x coordinate minus x and y coordinate minus 1 minus y. Here and this is minus x minus y coordinate and z. That means this is only reflection. If I will change the sign, if I will change the sign of imaginary part on this figure A and from this figure B, here is A figure and this is B from A and B figure only, you will observe that if point is in first quadrant, we are getting its mirror image. fourth quadrant. Here, if point is in a second quadrant, we are getting mirror image in a third quadrant. That means any complex I have that is equal to x plus I y be any complex number, then that only I will write here. Then this complex number x minus iy. This complex number is just a mirror image of my given. I will denote this as bar. And third bar notation is conjugate of complex. Where bar is called conjugate of. Therefore, I will write that notation conjugate of z. Any complex number is given. Conjugate of z is if z equal to x plus iy, then conjugate of z is denoted by that bar note, and this is equal to x minus iy. Only what we have to do, we have to make a change in sign of imaginary part, not in real part. Change it. Suppose my z is equal to 1 plus 2y. What is its conjugate? Z bar 1 minus. If my z is equal to 3 minus 4i, then its conjugate z bar is equal to 3 plus 4i. I have to make a change in imaginary part. If my z is equal to minus 5 plus 7i, I will write z bar. Keep a real part as it is. You change in sign of imaginary. This I will write minus 3 minus 2. That conjugate. Conjugate is 3 because real part. We are not changing real part. In of imaginary parts. Conjugate of given complex. Conjugate means we are finding its mirror image. Then I will take something. Magnitude of complex. Suppose I have this complex number z is equal to x plus iy, then its magnitude is denoted by mod z. Magnitude is denoted by mod z. Definition square plus 1. And I will define another term also, amplitude. Amplitude of z. This is also called argument of z. Also called argument of z. It is nothing but tan inverse of y. This is nothing but tan inverse of magnitude. Absolutely. And this is amplitude. Amplitude of z. I will denote in this way. Amplitude of z or argument of z. And this is always is equal to tan inverse of. I will rewrite here for given any complex number. I have any complex number x plus iy, magnitude of z is noted by r, is mod z, which is equal to f, and amplitude that is denoted by amplitude of z, or this is argument of z, or this is in theta, tan inverse of y divided. We'll go through what is by using magnitude of. I have this complex that is equal to x plus y. Generally, I am taking. So now use z equal to x plus iy by complex. How to plot? I'll plot in first order, and that is assuming that x and y given, not necessarily positive. It can be x and y, and I will so origin. And we are knowing that here by using a distance formula, and I will write here this key point, coordinates are z, y, and this OP. Now here actually OP, this distance, whatever that OP is nothing but z, which is equal to x plus iy. Actually, this OP is nothing but vectors. This is our complex. Now I will say that this is complex. Z is x plus. What is the distance of this OP? By using distance formula, we will find this distance. I will write here mod z, and this is your r. R why? Because the distance, and that's why we have r is equal to mod z. This is the distance of that point from origin and that point. We are finding the distance. That is the modulus. How long this complex number is from origin with respect to origin is our method. Now this is the method. Now what is meaning of theta? Argument or amplitude. How we are representing? Here, what I will do. This is my point x. I will take projection on x-axis, and surely we are getting here x point. I will take projection of this on y-axis. We will get here point y. We get this point. As this, we are saying that this is r. Modulus is r. Therefore, I will denote this as r. This OPD r. And we are knowing that if we will measure this OP, and what is distance with respect to x-axis, positive x-axis, OP and positive x-axis, I will say some distance, theta, angle between this OP and positive x-axis, I will say theta. Then I will write again here, I will write this distance r here, I will projection of this P on x-axis at point M. PM. What is PM distance? PM distance. PM distance is parallel to this distance. And what is OM distance? OM distance. This is projection on x-axis. Therefore, this first one x. OM is equal to x. This OP is R. Because we have to. Now tell me, this is x and this is y. Now tell me what is cos theta. Cos theta. For this, cos theta is equal to R. Cos theta. cos theta is equal to OM divided by x divided by r. So P is r, and from this we will get x is equal to r into, and what is sine theta? So this theta, sine theta, sine theta is y divided by r, means y is our PM divided by OP, y divided by r, 8 y is equal to r into sine. Means this complex number that is equal to x plus I bar, whose coordinates are p and y. Corresponding to this, we'll get a point P with the coordinate p and y, x and y. Can I denote? I will denote this x and or this p coordinate as x. X means this value r cos theta, and what is y? R sin theta. Means I can denote this coordinate r cos theta and y is equal to r sin. This is my theta. Again, using these two equations, I will find here y divided by x. What is y divided by x? Y divided by x is this term divided by this. R into sin theta divided by r into cos. R get cancelled, and we'll get sin theta divided by cos theta is the tan theta. Means I have tan theta is equal to y divided by x, and from this we'll get theta is equal to tan inverse of theta is equal to tan inverse of y, and this is nothing but our amplitude, which we use. Magnitude of z, magnitude of complex number is nothing but distance between this point P is corresponding to this complex number. Every complex number will be point P, and distance between origin and this point P is nothing but our. And amplitude, amplitude is the angle made by this position P with respect to positive. This is theta is equal to y divided. This is whole. This representation of this complex number is called Argand's diagram. This is called Argand. Okay, Argand diagram means graphical or pictorial representation of what we will learn here in this. Here we learn for any complex number x plus I bar, you can write here its conjugate x minus I bar, and x equal to r cos theta, y equal to r sin theta. So what is r? R is nothing but magnitude of z square plus y square, and theta is nothing but amplitude of z, or this is the argument of z, which is nothing but tan inverse of imaginary part divided by real. Oh, this is very most relation, and we'll build up a lot of things based on this relation in coming. Thank you.